We've talked about how to use antiderivatives to find the integrals, but what happens when you have an integral and you don't know what its antiderivative is? Well, there's several different techniques to use, and one we're going to talk about is substitution. Let's say we have an integral, and we're trying to take the indefinite integral of x plus 1 cubed dx. Well, we don't really know what the antiderivative of that would be. So what we can do is we can look at this and say, well, we know how, let's say we have u cubed, just to use a different letter. We know what that would be. We know that that would be u to the fourth over 4 plus c, because we know how to use that power rule. And this looks almost like that. So what we do is a method called u substitution. And we use these rules that we do know to find ones that we don't. So in this case, what we would do is we would say, well, u is x plus 1, because we want u cubed, and du would be, take the derivative of this, 1 dx, because the derivative with respect to x is 1. Do that separation of variables. So now we can substitute this in. So instead of writing x plus 1, we write u, and instead of writing 1 times dx, we write du, and then we can take the integral. Then once we've found that integral, we substitute back in for what u is equal to, and we have our answer. Now the trick is finding the u that also has a du, its derivative part there, so that you can use that substitution. So we're going to do a couple of examples to help you see that. Most of this just takes practice on figuring out how to see the u. So let's look at another one. Okay, so we look at this and we think, well, this stuff inside here, this is the derivative. So if I use this as my u, am I going to be able to take the derivative, or take the integral of that? So that would be the square root of u, or u to the 1/2, and it would be a power rule, so we would know how to do that. So we say u is 1 plus x squared, which means du is going to be, take the derivative, 2x and then dx. If it helps you to write out du dx equals 2x and then do your separation of variables, go ahead and do that. So now what we have is the integral of the square root of u, or u to the 1/2, times du, because here we've got u and here we have our du. So we substituted in our u and substituted in the du. So we can take this antiderivative, take the integral, and we know that that's u to the 3/2 divided by 3/2, or multiplied times 2/3. And always remember the plus c. Then we go back and substitute it back in, and our u is 1 plus x squared. And so now we have our answer. How about this one? What if we have the integral of x squared times the sine of x cubed dx? Well, we know how to take the integral of a sine function, and we know that the derivative of the x cubed is 3x squared. We have this x squared here, so let's see if we can use u is x cubed so that we can substitute this in. Now, we have a little minor difficulty. We've got this 3 here that's not here. So we need a 3 here. Well, remember, you can only really multiply by 1 to an equation, or you change it completely. So we can't multiply by 3, but if we multiply instead by 3 over 3, then we end up with 1/3. You can pull that constant out front that we don't need, times 3x squared times the sine of x cubed dx. And we've got u, and we have du. So we can rewrite this as 1/3 the integral of the sine of u du, which we know how to do. So see how we got this constant in here? By multiplying by 1 in disguise. So the integral of sine is negative cosine. So we have negative 1/3 times the cosine of u plus c. Don't forget that plus c. Very, very important. And we replace our u back with what we originally substituted in, and we have our integral. Now, you can also do this with definite integrals. So for example, if we have from 0 to pi over 4 of the tangent of x times secant squared of x dx. Well, let's first look at what we would substitute. Well, the derivative of tangent is secant squared, you know that. So let's let u be tangent, because then the derivative is secant squared x dx. So here's our u, and here's our du. So now we're to the integral of u du, which is a simple one we know how to do. Now, here's the difficulty. These bounds here, these are the limits of x. So you have two options. Option 1, you find your integral and then go back to these bounds. So we would have the integral would be u squared over 2, which means, and then plus c of course, and then that would be tangent squared x over 2, and you would evaluate that from 0 to pi over 4. The tangent of pi over 4 is 1, so we have 1/2 minus the tangent of 0 is 0, so we would get 1/2. Now the other option, let's see what color shall we use here. The other option is to change the bounds. So what you would do is you'd take your bounds and plug them in here, and then put the new bounds on your integral, and then just stick with u. So if we plug in 0, the tangent of 0 is 0. And then we plug in pi over 4, the tangent of pi over 4 is 1. So now we have our bounds on u. So these were the bounds for x, which gives us these bounds for u. And then we have u squared over 2 evaluated from 0 to 1, which gives us 1/2. And we don't have to go back to the x at all. So those are your two options. You can take the integral and then go back and use your x bounds after you've replaced it with x. Or you can just change the bounds and stick with u the whole way through. All right, let's try another one of those. Okay, I want you to pause the video and try to do this one on your own, and then we'll go over it. All right, hopefully you paused the video and done this one on your own. So let's look at this. Hopefully you saw that u should be x cubed plus 1, because du would be 3x squared dx. So this would give us the integral of u to the 1/2 du. And now we've got our two options. We can change the bounds here, or we can integrate and go the other way. So let's look at changing the bounds here. If I plug in -1 here, I get -1 plus 1, which is 0. I plug in 1 here, and I get 2. So I take my integral, the antiderivative is 2/3 u to the 3/2, and then remember with definite integrals, the plus c doesn't matter because we'll end up adding it and then subtracting it off, so it won't matter. So we evaluate it from 0 to 2. So 2 to the 3/2 is square root of 8, and then times 2/3. Square root of 8, so we've got 2/3 times the square root of 8. This simplifies to be 2 root 2. So we'll end up with 4 times the square root of 2 over 3 as our answer. Now the other way, remember, that we could do this is we could get our antiderivative. We'd go from here to our antiderivative and go ahead and put in our x and evaluate it from the x bounds. And again, you end up with 2 to the 3/2 times 2/3 and then 0. So you still get the same answer. Of course, you should always get the same answer. So either way works. Just remember, if you're going to stick with u, you have to change the bounds. So hopefully you can see how to substitute in u, and whether it's an indefinite integral and you're just taking the antiderivative and don't forget the plus c, or it's a definite integral where you have to pay attention to which bounds you're using to get the answer. This is going to take some practice so that you can recognize what u is and what du is. So in class, we'll do several problems, lots of problems, to make sure that you can see the u and the du, but you need to be patient with yourself and realize that this practice, even though it's a lot of problems and you're doing the same kind of things over and over, it's very important so that you can recognize what should be your u. Read the section, make sure you have written down any questions you have so we can go over them in class.